So here we are going to discuss the transit VPC and transit gateway. So in the earlier lecture, we had a problem of having a central VPC to allow internet connectivity. So how would we solve that? Okay. So one answer is to use a transit VPC. So and this transit VPC, which in normal words means a software VPN. So this is not something that AWS will offer. This is an architecture they can recommend or suggest. But now there's a newer, better solution which is called transit gateway that we'll see in the next in this lecture as well. Now the idea is that we have a central transit VPC and we'll have the public internet using a software VPN solution. So here's my transit VPC, and I'm running an EC2 instance with a specific software VPN, and I have other VPCs now in my architecture. So there's the one on the left hand side right here, which has like the EC2 instances, and I'm going to establish a VPN connection over the public internet between my VPC on the left and my transit VPC. And my transit VPC can also have a VPN connection between my corporate data center and my transit VPC. And we can also do this with another VPC and another VPN connection. Now the idea is that now that I have established all of this thing, we have transit connectivity and all the VPC and the location, because we have entire control over the software for the VPN. The idea here is that we have to make all the traffic flow through that software VPN in my transit VPC. And so because all your network traffic is going through your transit VPC, then you have full control over complex routing rules. You can even check overlapping CIDR ranges and you can make it work. You can even do network level packet filtering for implementing some higher level security. So here with this transit VPC architecture, we have defined a software VPN between all our things going through the central transit VPC, and we have full control over all the network going through that central transit VPC. So there is something there is something like that that is a problem with it, because it is a software VPN running on EC2 instances. Then you have to figure out how to make it highly available. You must run as your own EC2 instances, and in case if you are expecting more bandwidth, more traffic, then you need to make sure that EC2 instance has the bandwidth and the capacity to allow for more networking and out also. So this is something sort of to do it yourself, but this works from an architectural perspective. But as I said, there is a transit gateway as a solution. So if we look at a typical architecture and a network topology for your VPC, your customer gateway, your VPN connection, and the direct connect, and the direct connect, and so on, it becomes very, very complicated, because you allow some things to talk to one and other, and anytime you need another thing to talk to another thing, then you have to create maybe a new VPN connection, maybe a new VPC peering connection, and it can become very, very complicated. And so the idea is that as we grow our architectures, the number of accounts we need to have a better way of handling all the network topology in our accounts. And we saw the VPC transits, that was a possible solution. But here we have a transit gateway, which is going to be a more modern solution brought by the AWS. So the transit gateway, and the reason we introduce a transit gateway is that we want to have transitive peering between, I would say, like thousands of VPC, even on premises centers into a hub and a spoke star connection. Hub and a spoke star connection has been shown in this diagram. So why a star type of the connection? Well, you can look at the diagram, it looks like a star, and so you can see my transit gateway can connect my many VPCs together. They can also connect to direct connect gateway if we need it to, and also connect to on-premise through a VPN connection and a customer gateway. So similar to the idea of the transit VPC we had before, now we have a transit gateway and all the traffic will flow through the transit gateway. All the traffic will flow through the transit gateway. And we'll have control over how the traffic is going to be rerouted to different endpoints in our star network. So the transit gateway is an original resource, although you can pair together many transit gateways across regions, and to share a transit gateway into many different accounts, you use resource access manager or RAM for short, and that is one of the primary use cases for using RAM. So alongside transit gateway, you can pair transit gateway across regions, as we just say. So it has cross region support, and the route tables, you are able to limit which VPC can talk to which other VPC. So where we find these route tables are at the transit gateway level. So it works with the direct connect gateway, VPN connections, and one thing it supports, it's called like the IP multicast. So a transit gateway, to my knowledge, is that the only thing that supports IP multicast in your AWS network. Okay, only the transit gateway supports IP multicast. No other services will support IP multicast. And so if you are a architecture and your application is relying on IP multicast, then you have to use a transit gateway. So what does it give us at transit gateway? Well, instances in VPC. Instances in a VPC can access any other NAT gateway, network load balancer, private link, or elastic file system in other VPCs attached to the transit gateway. So here we have to edge-to-edge routing, and we have transitivity, and this is the whole purpose of the transit gateway. So let's say go for an architecture, and which we have the transit gateway. So the essential NAT gateway, and you really have to understand what's going on here first. So we suggest you look at this link have been given at the bottom of the slide, and look at the blog, and I will walk you through this architecture as best as I can. But take your time, try to understand and how that works, because if you do, then you are good to go for the VPCs. So the idea is that we have an egress VPC on the left hand side, as you are able to see the diagram, and within it we have a NAT gateway, and so we want these NAT gateways into two availability zones. So availability zone 1 and availability zone 2 to take all the internet traffic from my other VPCs in my architecture. This is something I have tried to represent to you before in another slide, but I showed you it wasn't possible because of the lack of the edge-to-edge routing for VPC period. But here, so we have two NAT gateways in two availability zone, and they are highly available. And then we have two ENIs, Elastic Network Interface, and these ENIs are going to allow us to connect our transit gateway. So our transit gateway in here is going to be connected to two VPC. So the app1 VPC and app2 VPC, as you can see the diagram. And through the editing of the route tables, here, we are going to allow any traffic running from the app2 VPC to all the way through my egress VPC, and get to the internet gateway here and talk to the internets. And why do we do this? Well, because we have more control here over how the internet traffic is going to be distributed. We also have the centralization of resources, so we don't need to create one NAT gateway and one internet gateway per VPC. We can keep all the other VPCs private and make sure they have to access the internet through the transit gateway, through the egress VPC. And so for this to work, you need to edit some route table. So here it says for 0.0.0.0/0 should go to the transit gateway internet, and then the transit gateway internet is saying, okay, anything that comes from the 0.0.0.0/0, like the all traffic should go to these Elastic Network Interface, and then it goes to the goes on to the NAT gateway, and so on. You look at all the route tables, and that's how it works. But something that is happening in that diagram is that app VPCs themselves, app1 VPC and app2 VPC, they cannot talk to each other. And the reason for that is that the transit gateway route table does not allow it. Currently these VPCs to talk to one another and that would be something that's very possible. So meaning that if you have transit gateway, it doesn't necessarily mean that everything is going to be paired with one another. You have to define route tables to allow things to be talking to one another. But hopefully that makes sense, and this shows you a correct architecture for having a central internet gateways and the central NAT gateway through my egress VPC, and that is through the transit gateway. And okay, so that was a lot of the information. I hope you somewhat grabbed them. And okay, that's it for this lecture. I hope you somewhat got confused and somewhat got understood all of the concept. So I will see you in the next one.